technology to be accepted needs to be understood. It's the fault of academia if this does not happen, let me tell you.
Lorenzo Masia, full professor at University of Heidelberg.
There's this message that, in my opinion, is not correct, that robotics should replace what we do. The idea is that we create technology that converge towards our needs. Why a system should do something for me? Because I don't want to do certain things, but I also want to do things better. So the symbiosis between the machine and the human or the biological counterpart is something that is reached in a mutual way. In science, and let me tell you, there are people that promises to land on the sun, and they do it, and eventually, this grant is accepted, but then they don't land on the sun. This is a mispractice. There are those that overshoot clearly, and probably sometimes even undershoot for what you promise, respect to what you promise.
Bonded by Science, proudly presented by Noble Blocks.
Thank you so much for joining me on the Bonded by Science podcast, Lorenzo. I'm so looking forward to unraveling all the things that you've been working on in these past years, and also to get your opinion on, what is the future of robotics and what can we expect to unfold in the research lab, but also commercially in the next 5-10 years. I noticed that you made a reference to Icarus in one of your articles. This was more of an overview article. Was this something that you thought of yourself, and is it true that this is a storyline that inspired you as a robotics researcher?
Okay, so good morning to everyone, and thanks a lot for this invitation. Well, it's not the story itself of Icarus that inspires me, even if it's something that is widely studied, especially in the first time of our studies in elementary school, or as well as high school. But it's more the let's say, meaning behind that in life a person needs to dare a bit to overcome its limits. His limits are her own limits. And this is something that I try to do a bit during my life. It's more a philosophy of life, I would say, not only in my working experience.
Yeah, to overcome your own personal limits, right? Because everybody, of course, will have different limitations, and then there's limitation of the human being, and it's we're not born with wings. We've always had a fascination to fly. History tells us there's a great story there, and yeah, some of the projects that you're working on are also both augmentation but also surpassing human limits. You are also quoted with saying, "The future of robotics seems to involve a more symbiotic interaction between artificial and biological systems." For the average person listening, and even for scientists in your field, I'm sure they are quite keen to hear what is it that you mean by that, and could you elaborate further?
Well, let's say that robotics tends to move towards human, and there's this message that, in my opinion, is not correct, that they should replace what we do. The idea is that we create technology that converge towards our needs, but we have to evolve ourselves in using this new kind of system or machines that we try to design. Why a system should do something for me? Because I don't want to do certain things, but I also want to do things better. So the symbiosis between the machine and the human or the biological counterpart is something that is reached in a mutual way, moving towards a convergence point. And when I speak about symbiosis, I speak about the capacity of learning how to use this machine. If we make an example that is very much focused on what I do, that is wearable technology. The capacity of using wearable technology is not intended that the wearable technology should move your limbs or walk for you so your legs do not move anymore. But it's more having a technology that increase the capacity of walking, of running, of lifting systems. And here we are talking about wearable technology or assistive technology. I mean, what is commonly known as exoskeletons.
So if I was just to recap that, some of the symbiosis that you're referring to is our mental agility to interact with the robotics that we design to enhance ourselves. Yeah. And that mental agility or training or skill sets, I mean, this is something that ideally should be learned from a very young age. We see that some of the most, some amazing athletes, they start their careers very young. What is your opinion on that? I mean, a lot of the projects I know that are unfolding and at least under the research name are usually focusing on rehabilitation, which targets older individuals. Not necessarily, but some, yes. Are robotics going to be designed for the youth, or like what are we?
Okay, so there is a sort of paradigm shift, especially in assistive technology. Assistive technology or robotics was created mainly in the field of rehabilitation engineering. This was the main idea in 1990s, and it's something that comes from MIT. The pioneering idea was from the lab of Neville Hogan and Hugo Krebs, that are two scientists that are at MIT, and let's say the symbiotic work that they had with at that time was the Institute of Neuroscience with Emilio Pizzi. So over the course of the year, this approach in rehabilitation shifted a bit, and from let's say application or medical application, rehabilitation engineering, let's say, had a sort of dichotomy, and there was the birth of assistive technology. This assistive technology is intended to assist people that are not, let's say, unhealthy, paralyzed, or severely impaired, but assisting people in everyday life. And then we talk also of collaborative robotics, but this is another branch. So assistive technology, with also the many results that we have in miniaturization of actuation, sensing, computational capacity embedded in the microprocessors that we have right now, is becoming portable and can be used also for example, wellness. And when I intend wellness, I am targeting a field that is huge, in which electric bicycle, right now, if we want to speak about something that is actuated, it's not a robot, of course, but it's actuated, has electromechanical actuators on board. Electric bicycle is actually dominating wellness and is a huge market. So I see, my field at one point, not only focused in the medical application, but also in wellness.
Yeah, and I 100% agree. I think that, building products that can serve two types of markets. So one, of course, where, budgets are often much more constrained, which is in rehabilitation. And then if you can find a way to make the application attractive for another market that can then help drive that innovation, as you've mentioned here, the wellness market. So was this a strategy that you had from the onset, that you could use one to drive the other?
No, this was not a strategy, but I mean, it's more than 15 years that I have been in this field, that I have seen a lot of progress in the technology that is on the shelf that you can buy. So before, you have to use quite large actuators to move one leg or one arm. Right now, you have quite compact actuation technology with a power-weight ratio that is very high. You can buy sensors really for a price that is ridiculous, putting everything together with these new commercially available boards that are, the several Arduinos that are around, the NVIDIA Jets and all this microcontroller. And it's more or less like bricolage. It's everything ready.
To your knowledge, what are the most utilized commercially available, I guess, exoskeletons or robotics? If I say robotics, that opens up to like a huge field. Like, could be anything from a single actuator. But like I'm thinking more in like exoskeletons, assistive devices that someone like straps on and like helps them lift boxes or whatever. What is your knowledge of the, the most sophisticated piece of machinery that's walking around today?
Okay, let's say that we have to distinguish two main domains. So, and let's remain in the macro domain of rehabilitation technology. So for rehabilitation, that is the huge domain, there are two subdomains, upper limb, lower limb. Upper limb was dominated by what was called the MIT Manus. That was this planar robot, the first rehabilitation robotics approach for upper limb, spin-off from MIT. Interactive Motion Technology was the company that was used not only for rehabilitation, but for a lot of studies also in, let's say, behavioral neuroscience. For what concerned the lower limb, we have instead a spin-off from Switzerland that become also a large company, still active today, was Ocoma, and that was the big Locomat. That was another setup intended to restoration of walking efficiency in people affected by neurological disease. Then we have still in lower limb, another, let's say, subdomain that is portable technology that are the rigid exoskeleton. And here there are, in my opinion, three main companies. That is Rewalk, Indego, and the last one, that is a French company that now I need to Wondercraft, something like this, that produced this powerful exoskeleton. I don't remember here. Its name is Atlant. But the main domain is upper limb and lower limb, and these are the major companies, in my opinion, operating that launched the market.
Okay, so now I'm going to jump into one of your projects, the Walk-On. Where would that fit into your categorization?
It fits into lower limb because Walk-On is a soft exoskeleton, and then I will define what is a soft exoskeleton. That is targeting lower limb, but it's different from the usual exoskeleton that are on the market because it belongs to that category that is called soft exoskeleton or exosuits. And this was something proposed or pioneered, let's say, by my friend Connor Walsh in Harvard. The biodesign lab. Right now, it is a field that is expanding. Is let's say, a complementary approach to lower limb because we are talking about soft technology, cloth-like technology, no rigid parts. Basically, you are wearing clothes. Inside there are actuations that usually are tendons, wires that are pulled by electrical motors or artificial muscles that are inflated by compressed air. So this is another approach. My approach is mostly on wellness.
Yes.
In fact, what we do, we applied this kind of technology to elderly population, so older adults, and we tested these things mostly over ground, so outdoor, not in a lab settings. Recently, we got a paper accepted on Nature Machine Intelligence, and this one was the first example on how to use outdoor a soft wearable exosuit on about a hiking path of 1.2 kilometers. And we found that there was a reduction of the metabolic expenditure. So it means that the person needs less oxygen and less muscular activation. That was consistent, so about 20%.
And what does the tech look like? So is it something that I walk into a department store and I see a pair of bathing shorts, and then beside there I can grab my walk-ons. So can you describe how does this look?
Yeah, well, this is the idea. Basically, it looks like a pair of pants.
Okay, like tights. Tights, then?
Tights, yeah,
okay.
The one that you use for yoga or let's say to go to the gym, a bit tight. And then on these pants, there are some inserts that usually are rigid, that are called anchor point, in which you lock the, let's say, one extremities of the wire. The other extremities of the wire goes into a pulley that is attached to an electrical motor, and this electric motor are located at the level of your waist, so located far from the joints that you have to actuate.
So how much would the tights altogether weigh?
It's less than 2.5 kilo, including batteries.
Okay, and I'm guessing that it can sort of take care of itself in terms of like I add weight so I can reduce. You said it reduced the metabolic, so at least it needs to take care of itself and then provide this additional boost.
Yeah, I mean the mobilization of the parts, the pens. The
Yes.
pens we're talking about literally 100 to 100 grams. The difference between the rigid exoskeleton and the soft exosuit is that rigid exoskeleton are powerful, but they have to handle the weight of their own structure. This case is negligible.
Okay. And in the publication, do you have some images of those pants, or is that something that is maintained under IP?
No. I mean, nature machine intelligence wants us to disclose the projects, the code, the computer-aided design parts. But for what concern exosuits, is more the capacity of tailoring or sewing this kind of things.
Okay.
We're not talking about rigid systems that you can open with computer-aided design programs. It's like designing a shoe. There's no science behind it. There's a lot of experience and crafting.
Yes, there are some studies that are looking at, distribution of your weight, in your insoles. And I think there's been talk about, trying to recapture energy in some form in the shoe. So yeah, it's not a huge science, but I'm sure if we dove both of us into it, we'd probably find some more innovation in the last, 5-10 years. So the soft robotics, do you see this as something that will outpace now, like I guess you would call hard robotics, or would you just say robotics?
No, I don't think. I think that they are, let's say, complementary aspects of the same field of application. The rigid robotics can absolutely deliver a power that is by far exceeds the one of soft wearable exosuits.
Okay.
So can be utilized, for example, for persons that are severely impaired, or they cannot support their weight at the level of the physiological joint.
Okay.
These are the rigid exoskeletons. So we are talking about lower limb. For what concerns exosuits, we are talking about a technology that can provide a partial or a fraction of the physiological torque that is used to walk, but also provide less support in terms of the physiological joints. So you have to imagine, let's say, an exomuscle, an external muscle put in parallel to yours, but muscles, they don't have supporting actions, are the bones that are supporting actions. So an exosuit doesn't have bones like an exoskeleton.
No.
Okay, so these are for people that have residual capacity of motion, exosuits, that is still present with a high percentage.
Okay, and the soft robotics and the walk-on technology that you guys are progressing, how far away are you actually, do you believe, from bringing something to the market? I think, a lot of people would find this super interesting to wear. I think people would want to, jump into a pair of pants just to like see how it feels to run a few extra kilometers or an extra 10K. I mean, like how do you see, what's the timeline?
Okay, the timeline, let's say, does not depend on us in the sense that the prototype that we have here, it's actually, quite nice. The only problem is that you have to run all the medical device regulation, CE certification. To be honest, this is not my job. And it is something that needs to be taken into consideration by, for example, my researcher, if they want to create a spin-off, or an external company that arrives by the projects and then bring the projects on the market with the refinement that is needed to be a commercially available system. So robustness, ergonomics, ease of use, safety, of course.
I agree when you say like, you've done your part. So like you've done your job, you progressed the technology enough, you've provided some evidence of its efficiency, you've sort of laid the blueprint for a commercial entity or someone with a commercial interest to pick it up. But do you believe that enough of that is actually happening? We have a lot of researchers working globally around the world on very sophisticated innovations. And now you have something that has been published in a really nice journal. You have the evidence. Who's lining up to say, great, I got it. Let's spin this out. What is your impression, not just of your research, but potentially other projects in your field that you've been exposed to, or your impression generally of innovations that are laid down by scientists?
Okay, so let's say that in softwareable technologies, especially for lower limb and upper limb as well, because I'm also an upper limb, the critical mass is not yet there, in my opinion. While we have a much larger critical mass for large language model, vision, machine learning, and so on, when we talk about robotics, the large critical mass is in industrial robotics and not other applications. Eventually drones, there is a large critical mass. Industrial robotics, you have a large critical mass. And when you have such a large critical mass and you have the formation of these professional figures, of course, also the job market incorporate replies and create strategic fields from which, training these people at the end of their studies, a PhD, postdocs from the university, and steering the market, because there's a need. In softwareable technology, I still think that the market is not immature, but is immature the critical mass, so there's no critical mass at the level of the university.
So just to come back on that, we talk about market. Some business developers would say that you often have to create a need because people often don't know what they want. And you mentioned wellness, and wellness is huge. And wellness is now extending into longevity. So I see, while I agree with most of what you said, I also believe that there is a market. And I'm more curious to hear about what you think is slowing the progress of, you have something that's ready. How often do you find that the research is being picked up by the right people at the right time?
It's the fault of academia if this does not happen, let me tell you. Because many times what I see is that we exercise ourselves in a fantastic, let's say, Icarus flights of technicalities and complexity, and the large public does not get the meaning. So a technology to be accepted needs to be understood. So if academia, especially in this kind of field, does not succeed in communicating clearly what's the message and how this kind of technology might improve certain aspects of people's life, no one will take care.
And I guess that would be coming down to the benefits, right? Because we often, we eventually will accept tech if the benefits outweigh, the fear. Then you have your early adopters, and then eventually it becomes normalized, and you have, a larger adoption. So what do you suppose people would fear?
What people will fear from my technology or in general?
What would they fear? So let's assume we have amazing benefits. We don't have to list them all now because I'm sure there's many. But let's look at what they would fear about putting on the soft robotics, or, someone that needs... I don't want to go into rehab because I think that's a very special mode of thinking. These are people that would often be very grateful to have a return of functionality, because, you and I, we're very fortunate and, generally healthy to my understanding. So we tend to take for granted the things that we have at our disposals until they're gone. But let's look at the general population. Like if we're focused on wellness, what would be their fear for adopting such technology?
Well, is that technology will not really provide what they expect. This is the main fear. I mean, there are no intrinsic danger in this kind of technology. I mean, if you have, for example, an electric bike, what is the main danger? That you go too fast and you fall down. If you have an assistive technology that you are wearing, what is the main fear? That eventually the technology impedes your movement because you're not expecting that kind of force applied to your legs, and then you fall down. I mean, these are not really high risk. We are not talking about drugs here. We're talking about something that you wear. For me, the main fear is that you take this technology and then it's not useful.
As a researcher, that would be your fear.
No, I think it's also as a user. I mean, how many times you wonder, if I buy these things, I really have a benefit. And if you don't have, you have to sell it back in the right time. So you need to, you buy a car. Okay. There's no restitution policy that you bring it back. Then you buy a car and you say, you know what, I don't like it. What do? You have to sell it. Then you have to go, you lose the value. It's exactly the same, in my opinion. So if this kind of things works, it's our business as a researcher to demonstrate it, but to put it in the right words, that every person that takes a technical paper understands this is not possible. No one would read, if it's not a roboticist, a paper on the transaction of robotics. You will go for a high-impact journals that is intended to cover a broader, let's say, part of audience. The message should be readily extractable. Otherwise, no one will assume that this technology is beneficial. Not on the large scale.
Do you believe that that's happening enough now? So when you say a broader journal, are there any journals that pop into mind instantly?
Well, the high impact factor journals, they are supposed to be impact factor because they cover the interest of a very broad and large population part. Okay, so, and that's why these are journals that technicalities are usually sent to the final part in the additional materials. But what is written on the journal should be really extractable in terms of meaning by a broad part of people, even if they are not from the technical scientific community.
Yes. Okay. So I agree. I have seen many journals that will put the introduction, and then the methods section, for example, that would come next. That would be pushed to a later point in the article for anyone that wishes to do a deeper dive. And then you would go into a summary, like some sort of discussion of the results, more or less comes quite quickly. So then the style and the writing tone is very different. They are choosing, as you said, a more broad application. But which journals do you know of now that are really, because one is about format. I know, there's a few, I think even Scientific Reports does that. I know Nature does it.
Well, no, I would say that Springer and Science, Nature and Science are the journals in which, if you publish there, that it should be something that is absolutely really acceptable.
But if you look at how much is published in those journals and how much innovation is actually happening, then you essentially, you have a funnel system with a very narrow funnel. So you have a lot of innovation, and then you have a very narrow funnel in the end. So I guess my point is which other journals are available, and if they're not, then maybe we're really just talking about a gap in academia, a gap in the communication of science that needs to be filled.
I would say that the major journal in which I aim to publish, for example, and I'm not a doctor, I'm an engineer, are usually Science, Robotics, Nature, Machine Intelligence. If I have something super fancy, I will try to go on science or on nature.
Yes.
These are let's say the main ones. Yeah.
That would be an ideal outlet for sure.
So these are the main journals. To be honest, it's not that you can publish always this kind of things. And as an engineer, I like technicalities for my community. And sometimes, if you want to really impact in my community, you have to go very technical. I don't go to that journals. I will try to go mostly on IEEE Transaction, International Journal of Robotic Research, because there's space to talk about something that people from your community will understand.
Yes.
Okay. So this is my approach. Let's say once in a while, let's say once in life, eventually people are good enough to publish on this very high impact factor journals. Most of us does not succeed. I am in the, let's say, large part. Few of us succeeds because they discover something new.
Right.
Okay.
Yeah. So I guess one of the, like if you're thinking about everyday activities, then many of the activities that we do require a high degree of dexterity. So, and I know that you've mentioned the word haptic a few times in our conversation, and we've also talked about sense and sensory systems. So how do all those three come together in your understanding or your fields? Because the next motor action is often dependent on the sensory information that it's just processed. So, or to a certain degree, right? So there is a prediction involved, but how is the technology around the sensing systems, and how does that relate to the dexterity of some of these Android-like fulfilling activities?
Okay, so I can talk about my experience in, let's say, sensing and then consequently choosing the kind of assistance that a person should receive. We are, as human, mostly visually guided. So we perceive our surroundings using mostly our vision. Animals don't do something like this. We know that there are animals using echolocation, for example. We see mostly in the surrounding environment during when it's bright, when there's a sun, and we distinguish color. Other animals, they see when it's night, but they do not distinguish color. So if you want a technology, in my opinion, that assists human and he's able to adapt to a different variation in everyday life, and let's talk about walking assistance, you need to have a technology that understands the surrounding environment. My group was the first group activating this kind of technology, including also vision. So I'm not an expert of vision. I would like to point it out. I use on-the-shelf algorithm for classification and detection of the surrounding environment. What we are quite strong in doing is, for example, using camera input that detects, for example, surrounding environment, stairs, and then consequently adapt the assistance of the exosuit in order to help people in passing from level ground walking to stair ascending. So this is, a very simple example, yet, right now it's something that is starting in robotics, especially for assistive technology, including vision, in order to understand what is happening around, and then giving this wearable technology the awareness of what is surrounding the user and the wearer. I've done for lower limb. There are people in Korea, for example, who are the pioneers in upper limb. So the school of Kyujin Cho from Seoul National University. I know that there's also Straking Yadosen University of Aalborg, you should know, in conjunction with Dario Farina, that now is at Imperial College, that they use vision for controlling the grasping action of hand prosthesis. And there are many other people, of course, working still. These are very simple example of people working in this field. We have done for lower limb assistive technology, especially everything concerning, for example, locomotion mode. So you're walking on the ground floor, The system detects that you're walking on the ground floor and assists, replicating more or less the same amplitude of walking of your normal walking. You approach stairs, the camera detects the stairs, ignite a higher assistance in order to help you lifting the legs more, let's say, in a higher position. And these are, this use, let's say, machine learning algorithm you can use. You can use also stereo camera with distance detection. But the principle is exactly the same, providing the wearable technology the capacity of discriminating event from the external environment and consequently then regulating the assistance.
Okay, so the short story is that it's mostly vision that is used to make, like, is the main control, not the controller, but it is the main input.
Depends on the application, I would say. Depends on the application. Some other actions are haptically guided.
Okay.
For example, manipulation. If we talk about manipulation, there's a huge component of haptics. And here we are talking about force feedback from actuated devices. That one is another huge field. It's like another huge branch of robotics. But there we go, not on vision. We have, let's say, the integration of both visual information and haptic information. This is another huge field in behavioral and cognitive neuroscience, I would say. For sure, haptics involves, let's say, the sense of touch. And this is, also in an exosuit is quite another huge question.
Yeah. So in some ways, it does mirror us as a human being, or just most creatures that are walking planet Earth, are that we rely on vision primarily to guide our actions. And when vision is out of sync of other types of sensory inputs, people often feel dizzy or nauseous when they are incongruent. So I think that is, I'm guessing maybe, obviously people in your field would know that vision is like the most dominant type of signal that is used for dexterity or for,
Well, it's used for, let's say, changing. For me, vision is used for let's say, is one of the main, let's say, reference inputs. So we basically, if we speak about, for example, sports. Okay, let's speak about tennis. You see the ball that is coming towards you. You have more or less a guess of what is the velocity of the ball, and if you want to hit it back, you consequently activate your muscles according, I would say, an amount of contraction that should let the action to hit the ball in an optimal way. This is usually not, it has a feedback response from the vision, but the input to your musculoskeletal system is completely feed forward. What does it mean? That when you hit the ball that is coming towards you, the action is so fast that once you launch your racket and you extend your backhand or forehand, depending on what side you are playing, the action cannot be stopped. There's no adjustment. So human is mostly based, like most of biological and living systems, from a composition of feedback action and feed-forward action. The faster you go, and the more the feed-forward
the more right you hope
inputting.
To be. So.
Well, you cannot control with high frequency, because the faster you go, the better you should be in terms of, for example, athletic gesture.
Absolutely. But actually, now that you've opened this, because my understanding is really it's about predicting in advance where the ball will be, and then often that prediction comes. And when you said tennis, so it's really about reading the player and not the ball, and the racket. I think there's like a couple. Yet
reading is visual feedback.
Yeah, you're using the visual feedback. Mm-hmm. You sort of process that information, and then, as you mentioned, then you make a prediction, and then you have your feed forward. I don't know, signal action. Thanks. Signal sounds too single. So your feed forward action, and then and then you hope that you're right, because as you said, once it's put into motion, then it's very hard to retract it. But that would be different for robotics, right? Because the integration and prediction time could be potentially a lot faster than us as individuals.
I disagree on one thing.
You do.
The prediction can be faster, but the output of the action in terms of motion is not faster.
Okay, very good.
And this is the limiting hardware that I was talking about.
And I think people will recognize that they've done that, like where they're like, oh, it's too late. So they've already processed that they've done something incorrect, but the motion has already happened, especially in sports. It can also be in everyday activities.
Yes, I mean, I would like to point out that the capacity, the bandwidth, the power weight ratio of our musculoskeletal system is still unmatched in terms of technology. You can generate a lot of force with electromechanical actuation, with, for example, pneumatic actuation. But when you have high force, you don't have high speed. So, and that's another question. I mean, this unfortunately, human is affected by anthropocentrism. This is something that I strongly realized, and sometimes I'm a bit politically incorrect.
Okay.
And that's the motivation why sometimes I wonder why we have to replicate us if there are many other organisms that are much better than us, especially, for example, in something that relates to numbers of degrees of freedom, manipulation, power weight ratio.
Okay, so you're just opening up the whole evolutionary
and longevity question.
But I think it was the most fitted, right?
Survived. No, it's anthropocentrism
for the environment, not necessarily the best creature, the most intelligent, or the most advanced.
No, okay, evolution. Evolution, I cannot digress. I'm not very much into.
Oh, but I think it is a super hot topic still, especially because AI has been on so many people's minds, and what will it come, and what is the meaning of life, and how do we get here, and the universe and all of its unfolding. So I don't think that topic will ever get outdated, no pun intended, but so it'll something that will endure with time.
But my question is, and let me cite this time, a British group, the Queen, who wants to live forever, ? I don't.
I think there are a lot of people that want to live forever.
Well, it's anthropocentrism. Our biological cycle is limited, luckily, and it's even too long, in my opinion. Technology should help us in arriving at the end in a proper way.
I'm so happy that you brought this up because, when I was thinking about our conversation, I was thinking about questions, what should we talk about? And at that time, I had this thought about, longevity and aging, and there's a lot of push that people want to live longer. Some people will say, well, they don't want to just live longer. They want to live more healthy for a longer period of time. And I suppose that is the right way to phrase it. But let's be frank. People want to live longer. They just do. And, if you can be healthy also while you're doing that, that's sort of like a +1. So people want to live longer. And I was thinking we're always going and looking at, what is, turning our epigenetics on and off. And people are like, oh, there's certain cells that, the proteins that, are responsible for turning things on and off, which can lead to aging skin and deterioration of so you basically just lose your ability to repair is the short answer. And they're looking for ways to turn on those abilities again. But then I was thinking, but if our fundamental existence is really just to replicate ourselves, then because some people talk about the genetic code and, we're supposed to procreate, and that's sort of the driving mechanism. If you look at any other ecosystem and any other population or kingdom, animal kingdom, then you'll see that is a driving force. And so aging then is a mechanism to ensure that maintains a driving force, because as people get, why is it that we cling to our age or to life so much? Because we're supposed to the mechanisms that have been put out to make us age are supposed to help propel this sort of creation or this, and yet we are fighting it now. And I thought, well, okay, well, it's not necessarily two tangents. Like you can live longer and still grow your population. That's not the issue. But I think what the issue is that as we get older, we can see that we cling to life more, and somehow it brings out a new type of trait, which I would define very simply as greed. So like you want more, you just want more. Regardless of what the want is, you just want more. So as you age, do we as individuals become more greedy? And that greed would not be good for procreation all around, because you would actually you would aggregate and you would accumulate wealth. And in this, wealth now we often, equate that to dollar signs or money. But 100, 200 years ago, 300 years ago, wealth was, access to food and water and other sorts of things. So I know that was very long-winded, but I just can't help but think that maybe we are designed to age and die, as you have pointed out. It's a physiological thing. And because if we don't, something else stirs. And I'm wondering if that stirring is greed, and if it's really just a safety mechanism for...
No, I am a poor mechanical engineer. So, all this philosophical question...
I know, sorry, we just totally, we flew into space. You know what we did? We put on your Iron Man suit and, we flew out to Mars. And, now we're in Mars and we're having this debate about life.
It will happen, maybe not in my generation. And to be honest...
Flying out to Mars in an Iron Man suit?
No, to be honest, it's not that Mars is supposed to be this fantastic and welcoming planet, but independently on this. So something that I have learned working with neuroscientists, I had the luck of being exposed also to neuroscientists, that brain is a greedy optimizer. So if a brain can work less, is happier, to be honest. I suppose that we are greedy optimizers also on a large scale. So not only at the brain, the physical scale and the community scales. This is the sense of evolution. The more you succeed in prolonging your life expectancy, the more you succeed in securing your, let's say, wellness, the better it is. What I can say is that if you look, for example, a few generations ago, also generations of our grandparents, if not our parents, things are changing dramatically. It's part of evolution. Let's speak about sports. Difference in generation between tennis players. We are talking about a difference in velocity of the ball of about 20 kilometers per hour on average. All the sports are now progressing towards higher physical capacity. And higher physical capacity might correspond also to, let's say, enlarged life expectancy, longer life. It's not a mystery that, the average age increased. Yet, I suppose that this will happen for many other things in the world, not only for humans, but also for other living creatures. Some will extinguish, some other not, will progress, will procreate even more. It depends, of course, on several factors. For what I can say in my lifespan is that I work in the direction of not, let's say, expanding the time span of an individual life, because I strongly believe that natural cycles must be respected in nature and cannot be, let's say, strengthened much artificially. What I do is try to, and this is my philosophy, at one point you have to finish your life. It's the way that you finish your life that plays the major role. In a small field where I'm working, giving the capacity to an old person to be independent, change dramatically his or her own life, and eventually change also about few years or few months, the life expectations in terms of time span. So if I am able to give my grandparents, I mean, I don't have any more grandparents, but I remember them when they grow older. Can you help me making grocery? Can we go outside? I don't want to go by myself. Why not having a technology that will support this person, provide them more physical strength, because we're talking about physical strength. On cognitive ability, this is not my field, but there are, for example, systems that will increase cognitive abilities. Glasses.
Yes,
They are not
absolutely.
robotic systems, but they increase the cognitive ability because you see better. So acoustic support, I don't know how is it called, the small things that amplify the earpiece, that amplifies the hear capacity, improve also, and robotics improve the physical capacity. This is what I want to do. I don't have any other ideas, to be honest. And this is the worries of most of the people. You want to arrive at the end of your life with the dignity. So you don't want to just die on a bed and staying in a hospital for about 2 years. You understand? So this is the thing.
I think, when we talked about the messaging earlier, where we were saying, like, what are the benefits that need to be communicated to the masses in order to get technology like this, like either to get more funding pushed in this direction, to encourage and keep talent working in this field. What would be the messaging that would be needed to give to the masses in order so that they understand its value and its benefits, so that someone will come along and say, hey, I'm going to revolutionize something. And how do you explain end of life to people? One of the reasons why people smoked for so long was because you always believe that it will never happen to you. Like nothing ever happens, nothing bad will happen to you. It always happens to the neighbor or to someone else. We have this, defense mechanism that our capacity for taking care of ourselves is quite poor. If it's beyond a couple of days or a week or a month, it really requires a lot of mental effort to think about, how you're going to be in 20 years. And I think this also goes to savings and finances. People spend because it's hard to imagine themselves 20 years from now. So this is the end of life message that we are uncovering here.
Okay, so if I want to be a bit incorrect, let me pinch a bit, let's say, my community, the scientific community. We should stop a bit being so sensationalistic.
What do you mean?
So
what do you mean by that?
It's like, promising really, the elixir of eternal life. Sometimes, in order to have more impact or to attract more attention, what we communicate seems to be the greatest innovation. No, it doesn't work like this. You should be more honest. Also in medicine, there are, let's say, this curing cancer, I know cancer pretty well because, the most important part of my life was completely wiped out. And I accepted these things as a normal process in nature, not believing to the study, we will stop cancer. And if you stop cancer, something else will arrive because nature would regulate. It's like a negative feedback, the Shellie principle. You will stop cancer, people will not die anymore. Okay, something else will come up. Okay. So, and let me give you a very simple message. Come on. We are not able to replicate the hair, and hair transplant basically take hair from your back and put on your top. And I know it very well because I have done it. And we speak about eternal life, but really, guys, so stop being so sensationalistic. So with a bit more humbleness and say things how they are. And the small, simple step forward are the one that wins, not the overshoot. small, simple step forward that really drives humanities.
This is fantastic because I've also been, exposed to some marketing sides of things. And when I first started commercializing one of the software tools that we developed at Aalborg University, as a scientist, you don't want to hype things up too much. You just want to say, this is what it can do. That's it. Like, it can do this.
But most of science is hypes everything.
You think so? I think it's worse on the other side. I think
no, I mean both.
Far worse.
The scientists,
I think scientists, they don't like hype. Like, you don't like hype. You're a classic example. You don't like hype. You just told me right now that we need to be far more honest, and that's great. And I think that we do need to be more honest. My concern is that maybe in research grants we overpromise. That's a whole issue altogether.
But that one is marketing. It's fine. It's fine.
Yeah, that's marketing. That's scientific marketing. But then we go to the other side about products on the market and the promises that they. So you're saying, let's be more honest. But I
think marketing in corporate is a bit more honest, unless it's not a scam. And I tell you why. Because if it's not honest, and then people just realize, after a few times, after a few weeks, that the product that they have bought, it doesn't work, the company shut down.
That's true.
In science, and let me tell you, there are people that promises, to go really in the sun, to the sun, to land on the sun. And they do it, and eventually, this grant is accepted. But then they don't land on the sun. Well, first because, it's like a star, and it's not a planet. But this is a mispractice. Most of the projects that usually are accepted when I submit a project are not the one that tells you know what, this is gonna happen. There are those that overshoot clearly, and probably sometimes even undershoot for what you promise, respect to what you promise, dramatically. I am totally convinced that progress happens with small steps. Then sometimes once over a billion. That's the change that revolutionize our society, that discovers something that really changed everything. To be honest, right now, nowadays, I don't see any.
So what would be a solution then? So I think you're right. I have also been aware of people over promising, and one of my pet peeves right now is hovering around this point that I think that there needs to be more accountability placed on scientists generally for the promises that they make. So, if we were to enforce, if we were to review the grants that had been accepted, the money that has been given, and the promises made to receive that, meaning that person won that grant over somebody else that made a different promise or had a different name even. Maybe that was the only difference between the two applications was the name. So if we were to, instill some mechanism where people and scientists were held more accountable for their promises, do you think that would encourage people to be, more honest? I'm not saying exactly the means of how we do it, like how exactly we would, develop it.
But listen, scientific community, first of all, is self-referential. So this means that the one that approves your grants and read your papers are scientists. And most of the time, there are what I've seen also. Sometimes, grants that is not accepted and then pops up somewhere else, someone that is doing exactly my same things, or people that don't cite your paper and you have done these things 2 years ago because they realize that they want to be, ahead of you. And for me, this is totally mispractice. You are lying, basically. The problem of the grants is just one. You are, let's say, unless you do not completely fail what you promised, or you don't do anything, you do not produce anything, no one is going to tell you, hey, next time you're not going to get it.
But that's because there's no accountability measures put into place. And I feel like it's a lot of money is being diverted from people that actually can make those incremental progresses that you just highlighted.
Well, then I would say that one is the fault of these few people that did not understand how to play the system. Because unfortunately, if you want to change the system, you have to go against a multitude of people.
Yes.
And, it's like Don Quixote fighting against windmill. Then someone will say, in terms of longevity, that life is too short for fighting against something that you will never win. Those who have done, they run a revolution. But how many times? How many years do you need to have someone that is a revolutionary person that change completely the world?
So you're saying, okay, let's go with the flow, basically, play the game.
Most of the people,
go with the
I
flow,
am one that goes with the flow.
Overpromise, underdeliver, but that's okay because you've made your incremental progress. So long as that continues to happen, then scientific progress is being driven. It's quite funny because it's like nobody really wants to address the elephant in the room. We'll just let it stay there, and we all can see that it's there, but we just keep going. And to draw upon the analogy, the motor command is already in motion, right? So you're just responding. We're just in the response phase now, and that we,
it's statistics. It's always statistics. So fissile materials start igniting a chain reaction when there's a critical mass. Arrive another part of material, and then statistically, you have a chain reactions. Now, the difference between, let's say, humanity and uranium is that you need to add the same uranium to create, the critical mass. In humanity, there should be instead a human that is completely different from the others in order to ignite a real revolution. And we had this kind of person. We had Nikola Tesla. We had Guglielmo Marconi. These people that changed completely. Edison as well, even if, it was quite a controversial figure. But of course, he was like a genius. We had Benjamin Franklin. These are the people that changed completely the path of history. In science, and there are also political people, but I am not very much into politics.
Yeah, so we've had some pretty amazing past figures that have often been working at the intersection of scientific discovery and it's more applied science that you're referring to here. So this is also, and we applaud these individuals. We emulate them. We use them as stories for inspiration. What do you suppose is happening now in terms of recognition and encouragement for the incremental processes in science? Do you feel that it's not happening enough, or that people are on pedestals and they shouldn't be there?
No. I don't want to be so, let's say, dramatic and saying that everything is wrong. Absolutely not. That evolution in terms of science is progressing pretty well, I believe. The technique that we are actually using is on large numbers, allowing people to do their own research, to have their own, let's say, freedom of proposing. And then sooner or later arrives someone that proposed something super fancy. And, it's like a progressive step. Okay, there are also, a grant scheme that are with very high risk of failure, because you have to propose something completely groundbreaking. I like this kind of things, to be honest. I like them a lot. Then how many of this grant really succeed in putting on the table at the end of the research this promise, super groundbreaking? 0.1% eventually. Yet you have to challenge people. It's the Icarus flight, who dares win. But in a grant, if you lose, you do not fall from an altitude that costs your life. Luckily, I would say.
So you think the investment is worth it, right? So we make these.
Yes. I don't want to be absolutely too, let's say, skeptical with the scientific community, also because I am part of it. There are, of course, criticism, but it's the action of the single, try to change them. Educating also people working with you in going in a direction that you feel that is more ethical to change the field itself. It's important that people in academia are the people that really do not compromise with ethics. Okay, so I mean, you need to be a bit draconian sometimes, and being something or being someone really, I mean, take the responsibility on your shoulder that you try to form the intelligentsia of the country.
Yes. Do you believe that there is an erosion of ethics happening now?
Yes, I tell you why. Because research sometimes is very much, let's say, ranked in terms of quantity and not quality. I mean, wins the one that has the largest numbers. And this is something that was not like this when I was a student. When I was a student, I didn't go on a Google Scholar and see how many citations it has. I was reading my papers, the paper, and the person that were super known were person that really, really deserved, because they wrote papers that were absolutely groundbreaking. They were at the tipping point. They revolutionized research. I can name many of them, also in robotics. So right now is quantity. How many papers you publish a year, how much money you bring, how many students you have, how many citations you have. And, sometimes quantity coincides with quality, but most of the times don't.
Yeah, because then it's just a matter of, probability, right? So if you have enough papers, something should be good. Right?
Oh, it means that you are a hard worker, nothing to say.
Yeah.
It means that you are an hard-working person. But there are people, for example, that with one paper changed the course of history. I mean, Shannon, that was a scientist, if I don't mistake, at MIT, and he was someone studying signals and systems, just wrote a paper on a theorem that right now is used in any field where you have to sample signals and then translate the signals into an information without losing information.
What would you say is then the right environment to really write and come up with ideas like that?
It's an environment in which you take research as a philosophy of life and not as a job. You don't go to work at 9:30 and then come back home at 4:30. You have something really in mind. You look forward to sit at your desk, coming back home and sitting in your studio, if you have one, and continue writing down. And eventually having a pause and having a nice run somewhere, swimming, yet thinking of when you will sit again. This is, where you craft. And this is not something that happens only in science, but happens in any job.
I agree. There's many industry positions where people are super passionate about the projects that they're working on, lots of innovation. It is a luxury.
Definitely. And if you have passions, and in this, American universities were, by far much more successful than other universities because they created what is called campus. I mean, when I was at MIT in the US, it was the best part of my life, also because I was a student. I had my lab there. I went there every weekend. And I had friends playing tennis with me, or we went swimming together, and then coming back to our lab. And then, hey guys, so let's meet tonight and let's have a beer together. And I had my locker with my shirts inside just to hang out at night. I still do this. I try to replicate this kind of philosophy also in my lab. I mean, most of the time when I interview for, going to another university, I say, well, most of the times also I meet with my students during the weekend. And there was the person for equal opportunity say, are you crazy? You force your person working in the weekend. And I say, absolutely not. So I go there because I like sometimes going there, and then I go swimming at one point. It's not that I go there only for working, but eventually also for reading my stuff that are not related to my work, or they are collateral to my work, yet converging towards, being me, a less ignorant person. And sometimes I find my students that eventually they craft their own things. They talk together I mean, yesterday we have also a nice, very huge celebration of a PhD student of mine that graduated. So this is the way you should input. You should give the person the idea of what not studying, not doing science, of working is. Unfortunately, you cannot do it with every job. But when you are young, when you have the freedom to do that, and universities should basically try to create this kind of environment, you win. Because these people then, when they go to other universities or in other working place, if possible, they will try to replicate this kind of environment.
You have how many PhD students are you currently supervising?
Well, I'm in variable right now. I mean, many graduated, but for now it's about 6, 7.
Yeah, and you've had as you said, many in the past. So what is your impression of the students today? So I asked this because I'm quite curious to hear about, because I know how I was when I started my PhD. I didn't view it as work. I just went like it was just something I did. And I know that that's how you feel, as you just explained here. The students coming in today, I feel like there's maybe like a dichotomy between, like, there's two types. There's some that are doing it because they want the credential, because they just want to get a promotion, or they want to, they're going to use it in a more strategic way. And then there's like the lifer. I don't have a better term for them, but the ones that just love the study. Do you find that the proportion of those is changing, or how is the younger PhD students, how do they compare now to maybe the ones that you supervised 10 years ago?
Well, let's say that I'm not a democratic person. So if someone wants to get a PhD with me, needs to have a certain passion. Then I get all the responsibility for his or her career. They get the merits. Yet they have to, let's say, support the lab in a proper way. This means that I don't want internal competition. Everyone will have his own or her own topic to develop. I want intersection. I want consistency. And consistency means like sport, it's exactly the same. You have to train every single day. There's no need to train 11 hours a day or to be in the lab 11 hours, 12 hours a day. There's a need to be consistent, to be in the lab, to talk to people, to confront with people in a positive way, in a constructive way. And it's exactly like training in a sport. Most of the times, the one who becomes the number one in a discipline is not the person that is the most talented, is the one that is most driven. Consistency means that if you are progressively training every day, you will be able to overshoot in no time, and in no time to come back to your pace without struggling. This is how works life for me. Consistency.
And do you see enough of that drive in your students today? We can just generalize here, because I know you have 6 or 7, so we're not going to pinpoint them out. But let's say, you have conversations with other supervisors. Surely you must have some talks about, the mentality that students have today. Do you think that there is enough drive?
You can create this drive, giving the example. You can literally shape, let's say, the working capacity and the ethics of a person with the proper input. And I do not confront myself with other supervisors, because I think that I am, quite, let's say, different as a person. I am not a leader. I am more a captain that plays in a team. I am still very much technical as a person. I do not impose one direction sometimes when there are problems. I discuss, I try to find a solution. I propose directions. Then, I let people free to develop these directions and increase the knowledge, also my knowledge. Of course, that at the beginning was like a starting point. But you have also to give them responsibility, to pay attention also to their, let's say, psychological attitude, understanding a bit, being, let's say, emotionally clever. Discipline when is applied in a, let's say, despotic manner, becomes dictator. And I am a very free person. I don't like to have someone imposing me anything. That's the motivation why I have very few mentors in my life, because those that were imposing to me did not have any success. And specifically in this moment of my career, and I mean, it's not super huge, however, in terms of time, but I work in 3 different continents. I have to say that at the end, I was right in rebelling in a certain direction and creating my own freedom.
So what have you observed? So you have your own way of running your lab. You aim to instill character and promote discipline and create an open dialogue, and make the PhD students take much more accountability for their own success from.
But you have to put them in a position of responsibility. This means that, presentation, for example, let's make a very practical examples. I run a lot of demo in my lab. I invited, I'm not kidding, hundreds of persons in 5 years here in Heidelberg University. And the philosophy that this is my lab is that you must be ready to run a demo with a working system every day, if there's a need. When a person visits our lab, attends live demos, can try the technology, wearing the technology himself or herself. But the person that explains most of the things, it's the students that is responsible for that kind of project. It needs to be done in a proper way. I don't like sloppiness. I like people that are professional, because being professional, explaining what you do, will create an advance for yourself when you will apply an interview for your job. It will give you credibility. It will give you capacity of confronting yourself with someone that eventually is visiting the lab, and usually are other professors that eventually will be the reviewers of your papers. It can be the next supervisor. It can be a person that sooner or later you will meet in your life.
I really like this philosophy because you are setting them up for success, making them ready to engage with anyone that comes across their path at any moment in time.
But, their failure in terms of professional attitude is my failures itself. If there's someone that fails in my lab, I don't blame the person, but I take it personally on what I should have done. Of course, with a certain limit. If someone doesn't want to work. But this is something that seldomly happens in my life, to be honest. Most of the time we're not people coming as PhD, but we're people coming from other labs in which the working attitude was not mine. It was a working attitude to say, hey, you know what? Today I stay home because it's raining. This does not work. It does not work in corporate. It does not work anywhere.
Do you have any thoughts on mentorship? So you just explained a lot, but what do you see happening in other labs that you feel is maybe distinctly different from some of your philosophy on how to mentor PhD students?
But also in many labs, that are successful labs, I think that quantity is the main strategy. When you have 50 people in your group, to be honest, unless you are not, this famous person in Italy was Pico della Mirandola that had this fantastic memory. You cannot remember all the names or all what they are doing. So the more you are in the lab with them, and I am systematically the first arriving in the lab because I don't sleep much, unfortunately, but it's fine. I still succeed in surviving and having a good pace. And mostly also one that goes away later. And what happens with this? Well, it's not that you give the example, but you have more time to spend with them. I don't have, for example, weekly meeting because I know exactly what they're doing step by step. We go to lunch together. We talk together. Sometimes I pass in the lab to the table. I talk to people as I go in there. So they know that I know if things are going in the proper direction. If they don't go in the proper direction, we'll sit together and we steer them in a proper direction. So I say, okay, increase here the speed. Take this. We have to publish that. Read this paper for, next week. I'm going to read it. Papers don't stay in my email or on overleaf because we use overneath online more than a week, 10 days. They are elaborated and they are sent out. Now, why can I do this? Well, I'm not a family man. So I am someone that has a lot of time to dedicate to my job. But this is choice.
It is a choice. Yeah. And I think there's some scientists that, like for me, I have 2 kids, and I brought up my kids while I was doing my PhD and progressed there. And
It's really, another job. So, I mean, I'm not sure that I would be able, I don't think I would be able to spend so much time in my working place.
yeah, I mean, there would have been limits, and maybe you would have chosen different strategies for your lab. Maybe you would have had another, like a partner in the lab that adopted the same mentality that you had. So it would have been a team effort. So I'm sure there could have been many possible scenarios where things.
Oh, there are people that are extremely successful also with large families, much more successful than me. I mean, and this means that they are by far much better than me.
But something always has to give. And I think this is we have to be careful that we don't create illusions for people. Something always gives. Your time does go somewhere. So if you are when you're in the lab all the time, that has consequences. In this case, it's a good consequence for your students and for your progress. But for people that do that also have other obligations, I mean, there will be consequences. So I think I just want to paint an illusion. I would like to make sure that people know that with hard work, as we mentioned here, I mean, you can accomplish a lot. And I think that's where focus comes, and, keeping your eyes on the goal and really not allowing yourself to be overly distracted by things that really don't bring much joy or value to your life. When you look back, I'm quite curious to know if there are any pivotal moments, like any forks in your road where you thought, okay, if I go here, my trajectory will take on a new, my career path or my personal life will be completely different. Did you ever have one of those moments that you're willing and able to share?
I have no regrets.
I didn't ask you if you had regrets. I just wondered if you, because I know you don't have regrets. I know you're happy and you are successful and you're doing amazing things. So
in a moderate way. I mean, successful in a moderate way. Happy is not always happy.
Well, it's transient.
Let's say.
Yeah.
Well,
I can see it. I can see it.
Otherwise, evolution stops if someone is completely satisfied and fulfilled. There are moments in my life that were pivotal. I think that, what I have done is try to optimize my choice, depending also on important things in life that were also my family. I mean, there was a moment in which I was in the United States that I wouldn't mind staying in the United States. At the time, MIT was considering also keeping me as a postdoc, but I had to come back because my family called. There was a problem with we talk about illness and cancer. There was a problem at that time, and I came back. And I tried to re-optimize my situation. I spent fantastic 5 years in the Italian Institute of Technology, where I learned a lot with fantastic colleagues. At the time, Italian Institute of Technology was like Coney Island for hardware and labs. Yet, I had to really fulfill my duty in helping my family. This was probably, the big sliding door in my life. So far, I might have stayed in the US. I would have probably regretted. Not for the being in the US, because it would have been fantastic, continue working with my group in the US, but I would have felt myself. And I am talking at the personal level, because I know that people says, okay, no, but I have my career and my family needs to, and I don't blame them. These are personal choices. I have been educated with a sense of duty and expendability. So you have to be expendable. You have to, let's say, not progress for your only, let's say, for your main satisfaction. You have to be able to have the large view and endure fatigue in silence for noble cause. I think, sometimes you have to give up to personal satisfaction and being able to provide things that on a global scale would improve.
Yeah, I agree. I think and that can happen on very different levels, right? What we give up. We have to understand that sometimes being uncomfortable is progress, and that there are sacrifices that you make. So, and hopefully you take them as a conscious choice, an informed decision. I could imagine though that it sounds like, despite that you had, you came home for the right reasons, but it sounds to me like you still found your way into the direction that it didn't matter that there was like a fork. They sort of collided again, or they rejoined at a later point. So it seems like you would have ended up here no matter what.
Well, one way or another, I would say yes. One way or another, it's like the same philosophy that I have of traveling. I am an addicted motorbiker because I came to Aalborg with my motorbike.
Yeah, that's when we first met. Okay. I was like, oh, okay, this is my kind of scientist.
So it's about, let me guess, it's about 1,000 kilometers plus from Heidelberg.
Yeah.
And I did it in 2 days. Sometimes I succeeded also in traveling 1,000 kilometers in 1 day. But then age now is telling me that probably I should stop and enjoy more life, in a nice place somewhere, and then continue riding. So you can choose to ride on the highway and arrive earlier, but you will not see anything. Okay. Or you can try to travel. In Germany, they say via Bundesstraße, that are the internal provincial roads. But you will experience a lot of things. You will enjoy the trip. It will take longer. It's harder because at the end you are riding for a lot of hours. But you will experience many more things. You will meet many more people. And at the end of the trip.
Well, so this has been a really, really amazing conversation. I'm glad that we got to touch on the mentorship part, because I think there's some key pieces of advice there that should be shared. And I look forward to following the Walk On project. So I hope that you will consider rejoining at a later time to give us some updates on some of your new developments. And maybe we can also bring in some of your PhD students as well, so that we can give them some more responsibility and they can join the show and talk about all their fantastic work.
Well, it's something almost official that I will join the Technical University of Munich in the next months.
Yes, congratulations on your new position.
Thanks a lot. And the team that is there is a team, of course, of person that I unconditionally admire, because in robotics, probably it's one of the strongest groups in the world. So they have a very nice project in Garmisch-Partenkirchen that is like a very nice place that is on the mountain, on the Alps. And they are developing their campus in a context of a project that is called geriatronics, an entire campus where geriatronics, like geriatrics, because Garmisch apparently is one of these places where people grow old.
Okay.
But they have a lot of healthy people, but because they hike, and they are in this enchanted place that is far from pollution and other things. So in the project of geriatronics, since I'm involved, what I will do is just replicating the device Walk On about another 10 times, and then making a fantastic advertising movie with the inhabitants of Garmisch-Partenkirchen hiking with the Exosuits.
Like a documentary of like the whole journey of bringing the soft robotics there.
Yeah,
seeing
absolutely.
How they're adopted, testing them, running the field experiments.
The idea is that one is how much this technology can be deployed on the ground and being part of everyday life.
Right, and I suppose in the city or this area, that it's part of their culture, right, to stay really active, and so it might even be harder for those that are no longer able to participate in what is considered, a main activity of that area. That could actually have a bigger impact socially.
Well, there is. I mean, sooner or later. You cannot just climb the Mount Everest. No, you have to stop. But there, of course, and Germany, for example, for this vanguard, so they like very much hiking. Is one of the main national um, thing. So people likes walking in their forest. They have fantastic forest here in Germany. Not only the Black Forest, the Schwarzwald, but I live in Odenwald, for example. That is where Heidelberg is placed, next by. And this is something, for example, that the more you're able to do, the better you will stay, at least, mentally. Yeah, I mean, being immersed in nature is like, it is one of the greatest luck, for sure.
All right. Well, thanks so much, Lorenzo, for taking the time to meet with me. And yeah, big reach out and thank you from Noble Blocks and our sponsors, of course. So yeah, super happy and can't wait to speak again.
Thanks a lot. Thanks a lot to everyone. Bye, Shen.